Okay, everyone. Assalamu alaikum. Let's begin then. So we were doing normal distribution, and in the last session, we learned how to find probability of anything using normal distribution, given some value of x and the mean of the distribution and the standard deviation. We learned how to find probability, right? We looked at a number of examples of that. We will have a look at uh, the concepts that we did in the last session quickly. And then we discuss inverse normal after that and do some questions on that inshallah. So let me quickly remind you about what we did in the last session. We talked about, we started a normal distribution by discussing this fact that it's a continuous distribution. The previous two distributions that we did, binomial and geometric, they were both discrete distributions. In continuous distributions, the values of the variables can also be decimals, right? So in normal distribution, you can have decimal values as well. Normal distribution that's described by mean and variance. Just give me a second. Just correct this. Okay, so in normal distribution, a normal distribution is described by mean and variance, right? That's what we discussed. This is the notation that we have. If you have something written like this, n, and then inside the brackets, two numbers, the first number always represents the mean of the distribution. The second number represents the variance. And then since in the calculations, we often have to use standard deviation. If you want to find that, you can take square root of the variance and that gives you standard deviation. Okay, that's what we discussed. And then for finding probabilities, we said we have to use something that we call a normal distribution curve. It's a symmetric curve that looks like this. The area under the graph represents probability. The total area, therefore, is going to be 1 under the graph. It's symmetric about the mean. So mean is there right at the center. As you get closer to the mean, probabilities become bigger. As you move away from the mean, the probabilities become smaller. Then we said, how exactly do we find probabilities? For that, we looked at this example where we said, if you take a test in some class, and let's say there are 100 students, and you write down their test scores, and you basically collect data about the test scores. If it follows normal distribution, let's suppose the mean turns out to be 60, standard deviation turns out to be 12. What you can do is you can represent this data in the form of a curve like this, such that the mean is right in the middle, which is 60, and your data is spread out like this, and you're supposed to find, for instance, probability of x less than 60, for instance. Since the curve is symmetric, you've got 0.5 area on the left side of the mean, 0.5 on the right side. So this area would be 0.5. However, if you have to find any other area apart from the left side or the right side of the mean, how do you do that? For that, you have to use the normal distribution table. Okay, and that's what we discussed. Remember, in normal distribution, we never talk about probabilities of a value being equal to something, because the area under a point is always 0. We don't talk about these probabilities. We always talk about probabilities of some intervals, probability of the variable being less than something or greater than something. We only talk about this, okay? Intervals, probabilities of some intervals. Now, how exactly do we do that? Areas under graphs, they're calculated using integration generally, but this integration is difficult. So for that, we said we have a table that we will be using for calculations. This is what the table looks like. This is called the normal distribution table. We learned how to use this table, but that table is only valid for a distribution that looks like this, that has a mean of 0 and a variance of 1. So whatever distribution that we have, what we have to do is, first of all, we have to convert it to a standard normal distribution. It's also called a z distribution. And the formula that we said we'll be using for that was z equals x minus mu over sigma. We understood the idea behind this as well, that when we subtract the mean from every value, the mean becomes 0. When we divide by standard deviation, whatever was the standard deviation before, it becomes 1. So that's the way this formula works. But then if you had to find any probability, for example, probability of x less than 70, what you do for that is the first thing you do is you convert it to z first of all, right? How do you do that? You got that formula for that we discussed. Z equals x minus mu over sigma. So in place of x, you put 70. So you have 70 minus 60 divided by 12 because the mean was 60, standard deviation was 12, and we find the corresponding z value. Once we have this, we go to the table and we find the value of probability corresponding to that z value. Okay, and that gives us the probability that we were looking for. This is what we did in the last session, but then there was some detail in this. What was that detail? The table only works when you have a format that looks like this. Now, this was very important, and this is going to be required today as well. This format, the standard format for using the table looks like this. You need probability of z less than some positive value. This is the only form for which you can use the table. If it's any other form, you cannot use the table. Table only works for this particular form. So when we have z less than something, z less than a positive number, we can go to the table and find that probability value. But if it's anything else, for example, if it's z greater than some value, we have to not use normal distribution table. We have to use normal distribution curve to convert it to that form. So z greater than 2.5, for instance, we said we could write that as, we could say the total probability is 1. We could subtract from 1 the area to the left of 2.5. And now this number is standard form. We can use the table for this. And we said we would find the table value from this, and we will get the probability from that. Similarly, we learned how to find all of these other probabilities when you have z greater than a negative value. How do you convert that? By flipping the curve. If you have z less than a negative value, how do you get that? By first flipping the curve and then doing 1 minus that, right? And then if you have an interval, we find the probability towards the left of one z value, subtract from that the probability to the left of the second z value. That gives you the probability for that interval. If you have both negative values in an interval, you first of all flip them, make both of them positive, and then you find the difference. And then sometimes when you have one value negative, the other positive, in that case, it became a slightly more complicated case, and we learned how to do that as well. Right, so this is what we have discussed in the last session, that if we have some information given, if we have a value of x given, we have the mean of a normal distribution given, and we have the standard deviation given, how we can find probabilities from that using the normal distribution table, right? This is what we discussed in the last session. Now, before we can do many questions, those of you who have looked at the worksheet, you would have found that every single question has some part that you cannot do using what we have learned until now, because this is the simpler part of normal distribution, where you have the x value given, where you have the mean given, and you have the standard deviation given, and you have to use these values to find some probability. This is called simple normal or direct normal distribution, in which you have to find probabilities. But the part that carries more marks in normal distribution questions is the one in which you're required to do the opposite of this, right? Inverse normal. Now, what is inverse normal? Inverse normal is that you are given some data in the question, that you would be given some data in the question, but you'll have something missing as well in that data, and you would have a probability given. Using the probability, you would have to find the corresponding z value from that and find that missing value therefore. Now, let me give an example, and that will help you understand this better. So we call this inverse normal because now we will be doing the opposite of what we were doing before, right? We will do it in the opposite order, in the reverse order. Now, let's take an example to understand this. Let's say you have a variable x, and this is normally distributed with mean mu. We don't know what the value for mu is. And the variance is, let's say, 9. Okay, that's what we have. We have a variable x. It is normally distributed with mean mu and variance 9. Now, using this, can we find the standard deviation? Because remember in the formula, so you have to remember these two things while we do this. The formula is z equals x minus mu over sigma, number one. And for the table, the standard form is this, z less than a positive value. Okay, that's the standard form for using the table. Keep that in mind. Okay, now, if you have a variable x that is normally distributed with mean mu and variance 9, and they tell you, given that probability that x, the variable, is less than 20, that is equal to some value. Let's say it's equal to 0.6341. It's equal to 0.6341. You are given a probability value. Using this, you want to figure out the value for mu. You want to figure out what mu is. So you're given that it's a normal distribution. Variance is 9. What does that mean? Sigma square is 9. So sigma is 3, square root of that. Given this information, we're looking for the value for mu, the mean of the data. So you see, it's the opposite of what we were doing before. Right? It's the opposite of what we were doing before. Earlier, we had all the values given, including the mean, and we had to find probability. Now we are given probability, and we have to find this missing value in the data, which is mu. That's the problem. Okay. Now, how do we do this? Before we understand how to deal with this, I first want you to understand how to read the table in the opposite direction. We have learned this in the normal direction already when we have the value of z given and we have to find the probability. We have done it in this direction. But what if we had to do it in the opposite direction, that we had a probability given and we had to find the z value from that? Let's understand how to read the table first of all in the opposite direction. Okay, we already know how to do it in the normal direction, right? If we have z value, we can say this is first decimal, this is second decimal, this is third decimal, and we can find the probability from that. What if you had to do the other way around? For instance, if you knew that probability that z is less than some number, this is equal to 0.8790. How would you find this z value? How do you find this z value? Ibrahim, I've seen your message. I'll do that inshallah. How would you do this? You have the probability given and you have to find the z value. Earlier, what we used to do was we used to look at the z values in the first column, in the first row, and we used to find the probability from that. Now we are given the probability. The probability is 0.8790. We would be looking at this region in the table. This region represents probability, right? We would look for that number in this region, 0.8790. Do you find that number anywhere here? Now, while you are finding that number, notice the values of probabilities. These are given in ascending order. So top left is 0.5. And as you go to the right, the numbers are increasing. And as you go down as well, the numbers are increasing. Okay? At bottom right, you see you've got the highest number in this table. So when you're finding a specific value, notice that they're in ascending order, so it's not going to be difficult to find. Let's find this probability, 0.8790. 8790, this is the value. This is the probability, 8790. What's the corresponding z value for this? Look at the left side. This is 1.1. Upwards, this is 7. So the z value that we have, therefore, corresponding to this probability, it's 1.17. That's the z value. Okay, so given this probability, we find the z value like this. Now, let's take a couple of more examples. Let's say we had some other probability now. So instead of 0.8790 for this probability, let's say it was 0.899. What's the z value corresponding to this probability? 8599. Let's find that. Do we have that probability here somewhere? 8599. This is the probability, 8599. What's the corresponding z value from this? On the left side, you've got 1.0. Above, you've got 8. So this is z equal to 1.08. Okay, so that this probability corresponds to a z value of 1.08. Now, these were fairly straightforward because the values that we were looking for, they were exactly there amongst those numbers written here, right? But what if that number was not listed explicitly in this region? What if we do in that case? Because remember, we used to add some numbers for the third decimal place as well when we used to find probabilities using z value. Okay, is it better now? Is it better now? Okay, so let me actually just write something here and that will make it clearer. Okay, thank you. So probability is 0.8599. The corresponding z value was this. What if we had some other probability? Let's take another example. So let's say we had a probability of 0.8753. What's the z value corresponding to this? Let's find this probability, 8753. 8753. You have 8749 here and you have 8770 here. There's no 8753, right? But 8753 is going to be between these two values, right? What we do is we take the smaller of these values. Okay, we take the smaller of these values. What's the smaller value? 8749, right? We wanted 8753. We take the smaller value from there. That's 0.8749. Now, how much do we need to add to 8749 to get 8753? What number do we need to add at the end to make 4953? 4. So what we do is we go to the right side and we see where 4 comes. This is 4. This is going to be the third decimal place for Z. What about the first and second? This is the first decimal, right? 1.1. And this is the second, which is 5. So Z value is 1.1. And then the second decimal is 5. And then we also have a third decimal because we have to add 4 more to it to get to that value. So the third decimal value has to be 2. So it becomes 1.152. Make sense? So we have to see what number we have to add to get that specific value. Okay, let's take another example. Let's say we had some other probability now. So we can do this as well. If it's hard to think of it mentally, you can write it down like this and subtract the 253 minus 49, that's 4. So we need 4 there for the third decimal place. Okay, let's take another example. Let's say we had a probability of 0.7080 and we want to find the Z value corresponding to this 0.7080. What about this? Can all of you try this quickly? 0.7080. Do you can you figure out what the Z value is going to be for this 0.7080? Where is 7080? So we have 70195488. So it has to be between these two numbers, between this and this. What we do is we take the smaller of the two. Take the smaller number. Now the smaller number, its Z value is 0.54. So it's going to be 0.54 for the first two decimals. What about the third decimal now? We want 7080. What we have found is 7054. How much more do we need to add to 54 to get to 80? We can subtract this. 80 minus 54, that's 26. Right? So we go to the right side and we see where 26 is. Well, we don't have 26. We only have 24 and 27. Where is 26 going to be? It's going to be between these two values. Is 26 closer to 24 or is it closer to 27? It's closer to 27. Since it's closer to 27, we select 27 from here and we say, okay, this is the third decimal place, which is 8. So if you cannot find that exact number there, you see which number it's closer to. Okay, so 26 was closer to 27, so we chose 27. The third decimal place turned out to be 8 for that. That's the Z value when probability is 0.7080. Okay, similarly, let's take another example. What if the probability was 0.5892? What about this now? 0.5892. Again, let's try and find that number there. 5892. It's going to be between these two numbers, right? 5871, 59110. What we do is we take the smaller of the two numbers. What's the smaller number? 5871. That's what we take from here. What's the Z value corresponding to that? 0.2 and 2. Okay, so we can write 0.22 here. And then, what number have we found there? We have found 0.5871. What's the difference? 21. We need to add 21 more to get that value. Right? Now let's go to the right side and see where 21 is. 21 is in the middle of 19 and 23. Now, is 21 closer to 19 or is it closer to 23? Is it closer to 19 or 23? That's the question now. It's exactly in the middle, right? 21 is the midpoint of 19 and 23. So what do we do now? we can take any one of the two. So if it's closer to one number, then you take that number. If it's exactly in the middle, you can take any of the two. If you want, you can use 19. If you want, you can use 23. Both of them will work. So for 19, you get 5. For 23, you get 6. And that will give you the result. Let's see what that turns out to be. 5 as the last decimal. It could be 5, or it could also be 6. Both of them are generally acceptable. Mostly, however, in the marking schemes, they write this number. They write the first number, the lower number. Okay. But you can use any of them. 0.225 is also fine. 0.226 is also fine. Or you can also use the midpoint of 2 to 5 and 2 to 6, which is 2255. But mostly you will see in the marking schemes, they use the smaller number. Okay. So you can use that. That will be safer. Although in practice, you can use any of them, and that works. Any problems with this? Does anyone understand how to read the table in the opposite order now, in the reverse order? Is there any problem with this? Okay. All right. Now, what if you had something like this? Probability is 0.8. What do you do with this? Remember, probabilities in the table, they're often written correct to 4 decimal places. So what if you have a probability that is not correct to 4 decimals? You write it to 4 decimals, right? If it's 0.8, what you would do would be, you would think of it as 0.8000. Okay? So think of it as 8000. And then find the corresponding z value for that. 8000. The smaller number from that is this 0.7995. We got 0.8 on the left side and 4 as the second decimal. It becomes 0.84. And then how much more do we have to add here? We have to add 5 more. This is 5. And that gives us 2. So it's 842. That's the z value that we get in this case. All right. So this is how we read the table in the reverse order. Okay, now that we know how to do this, now that we know how to read the table, now let's get to the actual thing now. How do we find this mean value? That was the question that we started from, right? How do you find this mean value? Yeah, so in the marking scheme, generally, what they do is they use the smaller value generally. Okay, they use the smaller value. So if you have 2 possibilities here, like in this case, when it's exactly in the middle, for example, 21 there was in the middle, we said it could either be 225 or 226, right? Both of them are acceptable. However, in the marking schemes, they generally use the smaller one. Okay, so I would recommend that you use that. That will be safer. Okay. All right, now let's get back to this example that we actually started from. This is the example that we started from. We had x as a variable, which was normally distributed. The mean was mu, variance was 9, and we were given this probability, and we had to find the value of mu. Okay, now what's the process for this? First of all, you think of this in terms of z. So you are given probability of x is less than this, but the table is in the form of z. So you think of this in terms of z instead. You say, okay, probability of x being less than 20, that is equal to 0.6341. But what z value does this correspond to? Let's find that z value first of all. Right? If x is less than 20, what's the corresponding z value for that? Now, how do you figure that out? This is the normal distribution curve, right? First of all, what we do is we write it in z form like this. Okay. The probability is 0.6341. We need to find the z value from the table. Okay. But we can't use the table unless we are sure that it is the standard form. What's the standard form? Z less than a positive number. It has to be standard form for us to be able to use the table. It has to be z less than a positive number. So we have to be sure that this number is positive, right? Otherwise, we would get wrong answers, or we would have to convert it to some other form first before reading the table. Now, how do you figure out if z is positive or negative? That is the question. So first of all, you write it in z form, and then you figure out if the z value is positive or negative. Okay. Now, this is slightly confusing in the beginning, so make sure that you're paying attention. Once you understand it, it becomes straightforward. Z can either be positive or negative, right? If z was negative, remember z is, in z distribution, the mean is 0. So in the middle, we have 0. If z was negative, where would it be on this diagram? It would be on the left side. This would be z if it was negative. We are saying probability that z is less than this value. So basically, we are looking at the left side of that value. To the left of that value, probability is 0.6341. Now, 0.6341, is that, in the context of probability, a large probability or a small probability? Remember, total probability is 1. Out of 1, this is more than 50%, right? More than 0.5. So if you compare it with 0.5, in a normal distribution curve, we know that left side is 0.5, the right side is 0.5. You think of this number as either being smaller than 0.5 or bigger than 0.5. Is this bigger or smaller? This is bigger than 0.5. If z was negative, then towards the left side of z, can we have an area that is bigger than 0.5? If z was on the negative side, can this area be bigger than 0.5? It can't be bigger than 0.5. This is less than 0.5. If z was positive, where would z be in that case? It would be on the right side. If z was positive, so if we were to place z on the positive side, now, can the area to the left of this z value, can that be bigger than 0.5? Yes, this can be bigger than 0.5. So what that means is z has to be positive. Z has to be positive. So this number, therefore, is positive. If this is positive, then it is the standard form. We can just go to the table, find the z value corresponding to this probability. 0.6341 is the probability. Let's go to the table. 0.6341 Let me write that on the side, 0.6341. What I'll do is I'll go to the other table. Probability is 0.6341. Corresponding to this probability, can you find the z-value? 6341. This is 6331, right? We have to add 10 more to that. You go to the right side. 10 is closer to 11, so we use 11 from here. So the first decimal is 0.3, and then you have 4, and then you have 3. So what's the z-value going to be here? Z-value is going to be 0.343. That's the z-value, 0.343. So now we go here, we say the z-value is therefore 0.343. And that's what we were looking for. We had the probability given. We had to find the corresponding z-value. Once we have that, now we know that z is equal to x minus mu over sigma. You can just input values in this. Z is 0.343. What's the corresponding x value? That's 20. Minus the mean. Mean is mu divided by standard deviation, square root of 9, that is 3. And that will give you the value for the value for mean. You can see what that turns out to be. 3 times 0.343, and then 20 minus that. This turns out to be 18.971. That's the mean of this normal distribution. If you want to round it off, that will be 19.0 to 3 significant figures. I can write this full as well. That's your final answer, because this is an exact answer. You can write all decimals like this. Is this process clear? Now, you might be thinking, what was the point of doing this right now? But it'll become clear in the next example now. Let me know if there's any problem until this point. Is this process clear to everyone? So we had something in the form of x. What we did was we converted it to z form first of all. And we found this z value corresponding to this probability. And then we used the formula z equals x minus mu over sigma, and that gave us the result. Okay. Any problem until this point? Any problems until this point? Okay. Now, let's take another example. That might make a bit more sense now. So this whole process would make sense. What if the variable was like this? It's normally distributed, and the mean is, let's say, mu, and the variance is 25. And now you're given that the probability that x is greater than 30, that is equal to 0.2. How do you find the value of mu in this case? How do you find the value of mu in this case? So what's the standard deviation going to be? Standard deviation is going to be 5, right? If variance is 25, standard deviation is 5. Now we've got this. X greater than 30, the probability of this is equal to 0.2. And what we need to do is we need to figure out the mu from this, the mean of this data. Now, to be able to use the table, normal distribution table, we need this format. Z less than a positive number. You can only use the table if you have this form. Okay. Now, what's the process that we follow? First of all, let's write it in Z form. So it becomes Z greater than some value, and we have to find this value. This should equal 0.2. So first of all, what we do is we write x in terms of x in the Z form instead. Okay. And now we've got to find this number. Now, is this the standard form? Z greater than some number? It's not the standard form. We cannot use the table yet. We cannot go to the table and find the probability 0.2. That would not work. Okay. you won't be able to find probability 0.2. It's not even there in the table. The probabilities there start from 0.5. So what do we do then? Z is greater than this value. The first thing you have to figure out is if Z is positive, if this number is positive or negative. If this number is positive or negative, that's the first thing you have to figure out. Okay, so you want to convert it to standard form, right? For that, you need to know if this number is positive or negative. Now, how do you do that? This number can either be positive or negative, right? Let's consider both possibilities. What we're saying is greater than means we're looking at the right side of that value. So Z could either be here on the negative side or it could be on the positive side. These are the two possibilities. It could either be here or it could be here. It could be either a negative value or a positive value. We are saying the area to the right side, the area to the right of the Z value, is it smaller or bigger? It's smaller than 0.5. So wherever Z is, to the right of that, we should have less area. We should have smaller area to the right side. Now, where do we place Z so that on the right side we have smaller area? If we place it on the left side, if we place it on the negative side, the area to the right, is that smaller or bigger? That's bigger, right? That's more than 0.5. That's not what we want. If we place Z on the positive side, is the area to the right of Z smaller or bigger? Now it is smaller, and that's exactly what we want. That means, again, the Z value here is a positive number. So this number here has to be positive. Okay, so we figured out that the Z value is positive. Okay. This is what we are looking for. Once we find the Z value, we can just input it in the formula Z equals X minus mu over sigma, and we will be able to find the value of mu. But it's not the standard form. It's Z greater than a positive value. Table can only be used when you have Z less than a positive value. How do we convert it to that form? We know that to the right of the Z value, this area is how much? This is 0.2. Now, if this area is 0.2, what about the area to the left of this? What about all of this region? If the right side is 0.2, this would be 0.8. So we can say the area to the left of that same number, if to the right you have 0.2, to the left you would have 0.8. Right? If probability of being on the right side is 0.2, that's equivalent to saying that the probability of being on the left side of that Z value is going to be 0.8. And how does that help now? This is now the standard form that you can use the table for. So you go to the table, you find the Z value corresponding to 0.8, and that will be the Z value that you get from this. You can see what that is, 0.8 probability. Let's find that out here. When the probability is 0.8, what result we get from this? Okay, the probability of 0.8, that means 0.800, right? So this is the smaller number than that, 0.7995. You have 0.84, and then you have to add 5 more. That's this. That's 842. The Z value corresponding to this is 0.842. You input that here. You say Z is 0.842. Now you use the formula. The formula is Z equals X minus mu over sigma. Input values in this, you have the Z value, that's 0.842. X value was 30 minus the mean. That's what you have to find out, divided by sigma, which is 5. And that will give you the value for mu. You can see what that turns out to be. Okay, 0.842 times 5. And then 30 minus the answer. That is 25.79. And that's what we were looking for. That's the mean of this distribution. Make sense? Now let's take another example. So this was when you had z greater than a positive value. What if we had something else now? So again, let's take another variable x. Let's say it's normally distributed and its mean is 6 and the standard deviation is, let's say, 1.8. Okay, that's what it looks like. Sorry, its variance is 1.8, not standard deviation. Variance is 1.8. And now we are given that the probability that x is greater than some value, let's say x is greater than a, is equal to 0.725. So you have the mean given and you also have the standard deviation given. So it's not necessary that you always would have the mean missing. You could have some other information missing from the data as well. In this case, we do not know what this value of a is. That's what we have to find out. We need to find the value of a. That's what we're looking for. Okay. How do you find this now? We know that the mean of this data is 6 and the standard deviation is going to be square root of 1.8, right? This is variance. Standard deviation would be square root of that. That's square root of 1.8. How do we start? First of all, we write this in z form, right? From the table, we have to find the z value somehow corresponding to this x value. So we write this in z form. We say z greater than some value, which we don't know what it is equal to 0.725. So we write this in z form first of all. Okay. Now, is this z value positive or negative? That's the first thing that we need to think about. Is this z value positive or negative? Can all of you respond to this? Is this z value going to be positive or negative? Can I have responses from everyone? Is the z value here going to be positive or negative? Positive or negative? Greater than sign. What does that tell you? We're looking at the right side. So z could either be on the negative side or on the positive side, right? These are the two possibilities. It could either be negative or positive. What we're saying is wherever z is, to the right of z, the area should be greater, right? You compare with 0.5. To the right side, the area should be greater than 0.5. Now, where do we place z such that the area on the right side is greater? If you place z on the positive side here, is the area to the right side bigger or smaller? Is the area to the right side bigger or smaller? Area on the right side is smaller. That's not what we want. We want the area on the right side to be bigger. So where do we place z then? We have to place z on the negative side. So that tells us that z is negative in this case, and this whole region, this shaded region, they're telling us is 0.725. So z is supposed to be a negative value here. Z is a negative value. Now, can we use the table from this? Using this, we cannot. It's not the standard form, right? We cannot use the table. That will not work, right? It's not the standard form. The table only gives us area to the left of a positive value, z less than positive. That's the standard form. How do you convert it to standard form now? We know that the area to the right side of this negative value is 0.725. Let's take a number, for instance. So let's say the z value was minus 1.5. We are saying to the right of this value, we have 0.725 area. Then what would be the area to the left of 1.5? If we had plus 1.5, what would be the area to the left of that? If we flip this, that will be the same area, right? So let me show you another curve here. So what we can do is we can flip this basically. We can flip it like this. We can say, okay, if the area to the right of this negative value of z is 0.725, then the corresponding positive value means if this is, for example, minus 1.5, its corresponding positive value will be plus 1.5. So the positive value corresponding to this, the area to the left of that, that would also be 0.725. So we can change this to, we can say it's equivalent to saying probability of z less than the positive value of z, that is 0.725. Now, is this standard form? Is this standard form now? This is z less than a positive number. It is standard form. We can use the table for this. We have the probability given. We have to find the z value using this, right? Probability is given. We need to find the z value. So now we can go to the table 0.725. Let's see the corresponding z value for that. If probability is 0.7250, right? Probabilities are correct to 4 decimal places. We can add another 0 with that. 7250, where is that? 7257. The smaller number is 7224. Okay, 7224, what does it correspond to? It corresponds to 0.59. What is the third decimal place going to be now? It's 7224. What do we want? 7250. 24250. How much do we have to add? 26, right? 50 minus 24, that's 26. Let's go to the right side. Where is 26? 26 is here. That's closer to 27. So we'll use this value. This is 8. This is 598. That's the z value. Okay. So that tells us that the z value is 0.598. Remember, that's the positive z value. Actually, z was negative. The actual value of z was negative. The table only has positive values. We found the z value, the numerical value of z. Now, the actual z, we would say, is negative 0.598, because that's what we figured out earlier, that z is supposed to be negative. That's why it's so important to first figure out if the z value is negative or positive. Otherwise, you'll get wrong answers at the end. So z was negative. So you have to remember, when you input this in the formula now, z equals x minus mu over sigma, you input a negative value here, that's minus 0.598, that equals x, which is a in this case, minus the mean was 6 divided by standard deviation, which was 1.8, and you can find the value of a from this and see what that turns out to be. Minus 0.598 times 1.8, and then you add 6 to that. The value of a turns out to be 5.1976. That's 5.20. To 3 significant figures, that's the value of a that we get. And that's what we had to find out here. Does this make sense? Any questions on this? Any problems on this? No problems? Okay, let's do one last example on this. One last possible case that we could have here. Okay, let's say we had something like this. We had a variable x, and it was normally distributed with mean 40 and variance 25. And we were given that the probability that x is less than b, that is equal to 0.215. Okay, let's say we've got this. Okay, what do we do now? What we're looking for is the value for b, right? You want to figure out what b is. How do we do this now? Again, we have to think of whether z is positive or negative, first of all. Remember the standard form? is this z less than positive number? We can only use the table if we have something in this form. Otherwise, we cannot use the table. All right. So what we do is we first of all write this in z form. So it becomes z less than some number. Probability that z is less than some number. That is equal to 0.215. Right, that's what we're looking for. Probability of z being less than some number, that's 0.215. Now, is z positive or negative? That's the first thing you have to figure out. Is z positive or negative? We're looking at the left side. On the left side, the area is smaller. The area is smaller than 0.5. Where do we place z? Do we place z on the positive side or on the negative side? If it's on the negative side, the area on the left side would be smaller. If it's on the positive side, area on the left side would be bigger. So it has to be on the negative side. That means z is supposed to be a negative number. Z is supposed to be a negative number. So this is negative, right? Z is negative. Now, that means it's not the standard form. We know that this area to the left of the negative z value, how much is this? This area is 0.215. Now, we cannot use the table yet. So what we do then is we say, okay, if the area to the left of the negative z value is 0.215, then what about the area to the right of the positive z value? What would that be? Area to the right of the positive z value, that will also be the same. This would also be 0.215. If that's 0.215, then what about the area to the left of this positive z value? This whole region to the left of the positive z value, 1 minus 0.215, and that's 0.785. So we can say this is equivalent to probability of z less than the positive z value being equal to 0.785. And now what we do is we go to the table and we find this z value from the table corresponding to 0.785. Let's go to the table and see where 0.785 is. 0.7850. The probability is supposed to be 0.7850. That's what we are looking for. 7850. Okay, we've got 7823 here. That gives us 0.78. Then 23 to 50. 50 minus 23, that's 27. We want 27 on the right side. That's this. That's 9 as the third decimal place, 0.789. Okay. 0.789 is the z value. So that's the z value that we're getting. 0.789 corresponding to that probability, 0.789. But remember, z was negative. Z was not positive. So now when you input this in the formula, remember to put a negative value. This is minus 0.789. That's the value of z. That's the actual value of z. It's minus 0.8789. Z equals x minus mu over sigma. Let's input values in the formula now to find that missing information. In place of x, we can input b. Mean was 40. Standard deviation was 5. And z is minus 0.789. And that would give us the value for b. You can see what that turns out to be. Minus 0.789 times 5, 40 plus this. That's 36.055. That's the value for b that we were looking for. Or you can round this off to 36.1. That's the value of b. Okay, so this is inverse normal. In inverse normal, what happens is you have some missing information in the data. So they will give you a probability. They will give you a probability, and you'd have something missing in the actual data. Okay. So it might be the mean that's missing. It might be the standard deviation that's missing. It might be the value of X that is missing. What you would do would be, you would first of all write it in the Z form and figure out if Z is positive or negative by thinking of the normal distribution curve and thinking of whether the area to the left is bigger or smaller, area to the right is bigger or smaller. You figure out if Z value is positive or negative. Okay, once you figure that out, you convert it to standard form, Z less than a positive number. If it's not already in that form, you find the Z value from the table, put that in the formula. If it's positive, you leave it as it is. If it's negative, you put a negative sign with that, put in the formula, and you get the result from that. Okay, this is inverse normal. Now let's have a look at a quick example on this, and then you will do practice questions. And tomorrow, or whenever we have our next class on Wednesday, inshallah, we will be doing practice questions on this, along with discussing binomial to normal approximation. Okay, so there's one thing that I want to do quickly before that. And this will be helpful for your notes. Normal distribution. Yeah. So there are two major things that we have done in this topic until now. One, when you have to find probability using the given data. In this case, you would have X given, mean given, standard deviation given. And what you would have to do would be, you have to first convert X to Z using the formula, right? If it's probability of X less than something, X less than 7, for instance, that you have to find out, you convert it to Z's. First of all, Z less than some value, and then you use the table to find that probability by first converting it to the standard form. Then you find the probability from the table. That was the first thing that we did. And then the second possibility is when it's inverse normal. Inverse normal. In this case, you have to find some missing data, and the probability is going to be given. Okay. So first of all, what you do is you write down the probability in terms of Z, right? You write, so if it's X less than something or greater than something, write that as Z greater than something or less than something, right? You figure out whether Z is positive or negative. Once you figure that out, you convert it to this form, Z less than a positive number. Then you use the table to find the value of Z, and you put the negative sign with that if it's needed. And then you use the formula Z equals X minus mu over sigma to find any unknown that you have. Okay, so that's the idea of inverse normal. This is just a summary of that. For your notes, I've added it to the notes. Let's have a look at one quick example. I was thinking of doing some questions today as well, but the turnout is quite low today. So what we'll do is we will do practice questions in the next class. I would recommend that you do a lot of questions for the next class now, apart from approximation questions. So when they talk about approximation, you can skip those parts. That's just one thing that we haven't done yet. The rest of it, you should be able to do. Okay. So you have to attempt those questions, and then we will look at some difficult questions in the next class, inshallah. I'll start with with one that is relatively straightforward right now. Okay, let's try this one. It basically touches on both the methods that we have done, and it's not that complicated as well. Question number 19. Let's try this. Okay, question number 19 from the worksheet. Let's have a look at this. It says the daily minimum temperatures in degrees Celsius in January in Ottawa is a random variable with distribution this. What does that mean? The first number represents the mean. Mean is minus 15.1, and the second number represents the variance. So standard deviation is square root of that. That's square root of 62. Find the probability that a randomly chosen day in January has a minimum temperature above 0 degrees Celsius. So we have data on daily minimum temperatures. We know the mean, we know the standard deviation. We want to find the probability of the minimum temperature being above 0. What does that mean? If we call minimum temperature X, what we are looking for is probability of X being greater than 0. That's the probability that we want to find out. Okay, we're looking for probability. So when we're looking for probability, that's simple normal, right? We have data given and we're looking for probability. What we do in such problems is, first of all, we convert this X value to Z value using the formula Z equals X minus mu over sigma. Let's convert it to Z. So it becomes Z greater than X minus mu. That means 0 minus the mean, which is minus 15.1, divided by sigma, which is square root of 62. And that will give you some value. You can see what that is. Z greater than what? 15.1 divided by square root of 62. And that's giving me 1.9177. Now, the normal distribution table has Z values correct to 3 decimal places. You are getting something that's correct to 4 decimal places here. So you round it off to 3 decimal places. So it becomes 918. Z greater than 1.918. That's the probability that we're looking for. Okay, that's the probability that we're looking for. How do you find this? Is this the standard form? The standard form looks like this. Z less than a positive number. We can only use the table. If we have this form, it's not that form. So what do we do now? We can draw a normal distribution curve. Let's say this is what it looks like. This is the normal distribution curve. Z is greater than 1.918, and a Z distribution in the middle, we've got 0. So 1.918, that will be on the right side here somewhere. This is 1.918. What we are looking for is this area. Now, the table cannot give us this area. The table can only give us the area on the left side. So what we can say is, let's find the area to the left side of Z. Z less than 1.918. Subtract that from 1. So 1 minus this, that will give you, so subtract from 1 the area to the left side, right? All of this region, you subtract from that from 1, and you will get this yellow region. Now, why is that helpful? Because now this is the standard form, Z less than a positive number. This is the standard form now. You can use the table for this. Go to the table. Find the probability corresponding to this Z value. 1.918 is the Z value. 1.918. Okay, 1.918. 1.9 is here. 1 is here. And 8 is here. We're looking for probability corresponding to this. We've got this number first of all. This is 0.9719. And then we add to that 5. We add 5 at the end in the last digit. And that gives us 0.9724. Okay, that's 0.9724. That's the probability that we have found from the table. It's 0.9724. You can find this out now. This becomes 0.276. 0.0276. That's the probability that we get from this. That's what we were looking for. That's the probability that on a randomly chosen day in Ottawa, the daily minimum, the minimum temperature is above 0 degrees Celsius in January. Okay, it's a very low probability. Make sense? Let's look at the second part. Now it says in another city. So now it's a different city. The daily minimum temperature is a random variable with this distribution. Distribution is that it's a normal distribution. Mean is mu and variance is 40. In this city, the probability that a randomly chosen day has a minimum temperature above the 0 degrees Celsius, that probability is 0.8888. So probability of x being greater than 0, they are saying this probability is 0.8888. We need to find the value of mu. Mean is missing. That is what we want to find out. What is the mean value going to be? That's the question now. Now you see, this is inverse normal. We have probability given, and we have something missing in the data. Mu is missing. That's what we have to find out. What's the process for this? First of all, you write this in Z form. So you say, this corresponds to Z greater than some value that we have to find out. That should equal 0.8888. Okay. Now, we need to figure out whether Z is positive or negative. How do you do that? You can think of a normal distribution curve. This is what it looks like. Now, once you've done some practice, you might be able to do it without drawing this curve like this as well. But for the first few times, I would recommend that you draw it. That will make things easier and less prone to errors. You can either place Z on the negative side or you can place Z on the positive side. These are the two possibilities. On the right, to the right of the Z value, area should be bigger. Right? You should have bigger area on the right side. So where do we place Z now? Then if we place Z on the negative side, that is when the area to the right side would be bigger. So this would be 0.8888. So that means Z is negative. The actual Z value is supposed to be negative. Now we can not use the table for this. This is not the standard form. We are given that this region is 0.8888. And that's what we are given, that this area is 0.8888. How do we convert it to standard form? Now, if we say, let's flip it. So if the area to the right of 0.8888, if the area to the right of the negative Z value is 0.8888, then the area to the left of this positive Z value, if we flip this, what should that be? That should also be 0.8888. So we can flip this. We can say Z less than the positive Z value, this probability should be 0.888. And now this is what you can find from the table, right? This is the standard form now, Z less than a positive number. Find the probability 0.8888 in the table and see what that turns out to be, 0.8888. Okay, so we got this directly here. This is 0.8888. This is 1.2 and 2, 1.22. So the Z value turns out to be 1.22. But remember, the actual Z was negative. So this is the positive Z value, right? When we flip that, but the actual Z was negative. So we say Z is actually minus 1.22. Now you input this in the formula, x minus mu over sigma. Z is minus 1.22, that equals x, which is 0, minus the mean that we have to find out, divided by the standard deviation, which is square root of 40, right? Variance is 40, standard deviation would be square root of 40. And that will give you the value for mu. You can see what that turns out to be, 1.22 times square root of 40. And that gives me 7.72 to 3 significant figures. That's the mean that we were looking for. That's inverse norm. Is this all right? Make sense? Any questions, anyone? Any questions on any of these two parts? Okay, now for the next class, please make sure to attempt a lot of questions from the worksheet. And if you have any problems, then let me know in the next class. There are some quite tricky questions, which you'll only find out when you practice. We will do some of them in the next class then, inshallah. And also, if we have enough time, cover the binomial to normal approximation concepts, inshallah. Or maybe what I'll do is I'll cover binomial to normal approximation. Then we will see whatever time we have, we will practice. Then we could have another session for practice later on normal distribution as well. Okay, but make sure to attempt questions because this right now the concepts are fresh. If you don't practice right now, you will end up forgetting these things. So do some practice and let me know the problems that you have. Okay, that's it for today. I'll see you again on Wednesday, inshallah. Allah Hafiz.